Okay, I want to talk about this subject called data archaeology or data rescue. I'm probably not the best person to talk about this, and there are some very good people, especially Pat Caldwell from Hawaii, who was hit by the US government problems and couldn't rearrange his travel. But I've had help from these people, and I'll do my best with this subject. What is it? What is data archaeology? Well, for me, it's an attempt to convert old measurements, there are lots of old records of sea level and other parameters, recorded in various paper ways, into computer accessible form so that we can all analyze it using modern methods. And these paper records, of course, include tide gauge charts, tabulations in ledgers of ports like Liverpool, libraries, museums, private collections, etc., etc. So it's stuff on paper, mostly, sometimes on old mag tape or something like that. But the data people, like Leslie, can be very boring. They can actually spot the difference between data archaeology and data rescue, but to me it's the same thing. But to be pedantic, to be precise, that data archaeology means seeking out and doing something with it, whereas data rescue means converting it into electronic form. But for me, it's the same thing. It's basically getting the data and getting it into a computer. Why do we want to do this now? Well, as Annie and others have shown, we want to be able to push the instrumental record of sea level back as far as we can. It's primarily a 19th, 20th century record, and we want to push it back as far as we can into the early 19th century, maybe the 18th century, if we can do. And so that we can complement other methods of measuring sea level, such as salt marshes. And a constant worry is that there's all this stuff on paper, but if we don't do this work now, then some of that paper will get destroyed. And I've spent a lot of time in libraries, and I can tell you that records get, a couple of percent of records get lost every year. So this is a couple of percent of our culture, our heritage gets lost for various reasons. So we have to really have some urgency about archiving and safeguarding the data. The first type of data that you really want to look at, I think, is tabulations. You might know that the first, what we call a tide gauge, really started in the 1830s. In Sheerness and other places. And they called them then self-registering gauges. But before then, what sea level was really records of heights and times of high water, and sometimes of low water. So there is quite a lot of this around the world, and as we're in Liverpool, I thought I'd mention my local hero, who's William Hutchinson, and he measured heights and times of high water from 1764 to 1793. Which is a remarkable achievement. This is a page from his Tide and Weather Journal. You probably can't see too well, but this is the height and the time of high water down here. The height is in... maybe it's my pacemaker. The height is in feet and inches. But he recorded many other things as well, as you can just about see. Here's the air pressure measured in inches of mercury, temperature a couple of times a day in Fahrenheit, and there's also a column for rainfall. There's wind speed and direction. This is 30 years of this data. It's a fantastic achievement, really. And but I want to make. I could give a talk about Hutchinson. I'm not going to, but I will do if you want me to. But I want to make 2 points about this. One is that until the mid-1990s, I had no idea that this data existed. It was, mention of it was buried in a card file in the archive of Liverpool Public Library. So how do you know it exists, even? Now, of course, libraries have computerised catalogues, and usually they're on the web, so you can search them out. But even so, I'm sure there's a lot of data still buried in libraries. The second important thing is we've got really absolutely no clear way of how Hutchinson made his measurements. We know where he made his measurements, where his tide gauge was, and we even know the name of his colleague who worked with him. But we have no detailed idea about how he made the measurements. So, for those of you yesterday who came on the field trip, you may remember I gave a speech standing pretty much where this artist, this picture was made, painting was made by Herdman 20 years after Hutchinson had died. But it didn't change too much. This is the old dock at Liverpool. And I gave my speech standing about here, you might remember. So and the main road at Liverpool goes up and down here, like this. Now, the tide gauge was about here, we know that. We know that Hutchinson lived in this house here. He had an observatory to make air pressure measurements, etc., on his roof here. This here is a sundial, so he could calibrate his clock, his watch, with the sun, when they had the sun in Liverpool. And so he was right on the job, and he was right on the job for 30 years. But having this kind of information is really important to understand. It's not just a bunch of numbers. You have to have some feel for how good the numbers are. So it's not just, you need to know how and why the measurements were made, who made them. And this can lead to a lot of research into local history in that way. And also you have to realize that most older measurements were not made for science, but for operational and other reasons. So you have to be a bit careful then. So you have to know how good the data is. Are there other data nearby you can compare to? Did the people measure other parameters like air pressure? How good a job did they do? So you have to have it's kind of qualitative as well as quantitative. So quite a number of other people have done this work. Really, I think one of the best of the modern era was by Martin Ekman in Stockholm, who looked into old Swedish records and did a great job with the Stockholm long record. Guy has done a lot of work with Brest and Marseille. Marta Marcos has produced a record for Cadiz. And sometimes the data rescue is only for a short number of years, but even so, that's useful. So Fabio Rajcic data rescued data from Trieste and extended the record for that. So there are many other examples of that kind of work. And what you end up with is a nice long record, which, if you're lucky, spans 300 years. But it is sometimes useful to have data rescue of short records. And good examples here are the ones that David Pugh was involved with at Port Arthur in Tasmania and Port Louis in the Falklands, which are due to measurements that were made in the 1840s. And also Laurent Testu's records from data rescue from Kerguelen and St. Paul, which all of these had to be searched out from libraries and archives. But even though these are short records, they can be combined with modern measurements so we can get insight into recent sea level change. So I want to mention briefly the record 6 months that James Clark Ross measured in the Falkland Islands. Now Ross did a fantastic job. He measured sea level for 6 months every half an hour. Okay, so it's quite a nice record. Those records went to the UK Hydrographic Office, and they've lost them. Okay, so this is an example of the 2% attrition rate that I mentioned before. That somebody should have been sacked, they're probably promoted or something. But it was saved by, a situation was saved, but you see here, these are tabulations of high and low waters. And these were produced by William Whewell, and who was a master of Trinity College in Cambridge. And Whewell is important for us because he invented the word science, which is even more impressive than inventing barostatic. So anyway, we have these high and low waters from Port Louis for 6 months. And Ross measured with respect to a very impressive benchmark that he set up, which has a brass plaque on it, like this, like so. So we know the sea level in 1842, actually. This is the benchmark. You couldn't miss that, a very impressive benchmark. And, okay, so you know the sea level in 1842, you have modern measurements, and from that you can infer that present-day sea level is rising faster than it was over most of the intervening period, which is a bit scrappy, but it's good to know. It's good to know. There's a similar, Ross was involved with a similar measurements at Port Arthur in Tasmania, This is actually John Hunter, for those of you who know him. And he's pointing to a benchmark here that was set up with respect to the tide gauge that Lampriere was using in Port Arthur. And this goes back to what Gary was saying just now. Actually, we don't care about tide gauges too much. What we care about is the benchmarks. You can always go down to the shop and you can buy a tide gauge. You can't go, if the benchmark is destroyed, you can't do anything. Okay, so, and then as for the previous plot I showed, where are we here? Port Arthur, the long-term sea level change is about a millimetre a year. We know the modern change is about 3 millimetres a year. So again, it's more evidence that sea level is rising faster now than it used to. Okay, but most of the data rescue is to do with digitising tide gauge charts. As I mentioned before, tide gauges, am I resonating with that? Tide gauges really came in the 1830s. Most of the UK charts were every weekly or fortnightly charts. And they were actually very clean things here. This is one from, actually from 1985 from Tilbury. They're very clean objects. So some centres have a lot of these, and the main issue really is how to digitise them and decide which are the priority. And so you might decide that to digitise interesting events like tsunamis, or if you have good benchmark information with the charts, then of course you might want to digitise them all for mean sea level studies. And you can work with commercial companies to do this work. Liz Bradshaw has a report for those of you who want to know how to do it. BODC are doing this kind of work now for all their archive, and you can find out about that on this website here. Okay, so again, other groups in Britain who've done this kind of work, people in Belfast, Ivan Haig, who can't be here today for some reason, a storm or something. On the south coast of England, English Channel ports, Chris Watson, Isabella Arroyo, and Marta again, and probably others. Done a lot of digitising. The really impressive one actually is in the US. This is a picture of the first US tide gauges that were made by Joseph Saxton for the US Coast Survey. And these are remarkable devices. And the one remarkable thing about them is they produced charts which were not nice little weekly charts, but these things were 20 metres of paper, that's very hard to handle that sort of thing. And how do you digitise that? But they've used photographic methods, and what's made the job easier is that in the US there were 2 tide pole measurements every day, which you can see here superimposed on the trace of the tide gauge. And that's really excellent information. So if you want to know more about that, Professor David Jay and Stefan Talk had a paper in the Journal of Coastal Research recently, which shows the work that they're doing. And they plan, I think, to digitise all this historical US data. Okay, so we have to assess the magnitude of the work, how much old data is out there, libraries, etc., and see what we could do if we had more money like Gary wants. Then we can estimate the potential improvements to global data sets. Now, this kind of work, estimating how much data is out there, has been done in some countries, and especially in France, based a large part on Guy's work and the thesis of Nicolas Pouvreau. And you can look at the French website, which is in English, and you can see what data that they've got there, which is very nice. Or at least they can see which data they could digitise if you wanted to, which is almost as useful. I've been asking Leslie for a UK catalogue for maybe 30 years, and I'm not going to give up. A combined UK catalogue combining the BODC and the UK Hydrographic Office and the Royal Society archives, but also we need to know what local libraries have got. And there are several holy grails. For example, we know Jeremiah Horrocks, who was a genius of a man. He measured sea level here, not far away from here, for 3 months in 1640. And these records might have been lost in the Civil War, but maybe not. Maybe they exist somewhere. So we really have to do a proper search for things like that. Now, globally, Pat Caldwell has been doing a global survey with questionnaire survey as part of GLOSS, and also an organisation called CoData, which is the club of data people. And he's identified 4,000 station years of data which could be rescued, tide gauge charts which could be rescued if we had the resources to do that. Shown in these places, like so. But these actually include the Talc and J US data I mentioned before. BODC had a similar exercise a few years ago, and they identified 1,400 station years. And the present exercise has identified 4,000 more, so we have to repeat this every few years in different languages, of course, to see what's out there. This is Pat's report if you want to read it. Now, finally, I'd just like to mention historical metadata. Now, we need to interact with the historical metadata community for several reasons. The most obvious thing is that, okay, you get some historical sea level data, but you want to understand it, and to understand it, you need to get air pressure data and winds if you can. So that's one reason for getting metadata. The other thing is that air pressure data can provide an essential cross-validation of the sea level data. So this is, again, this is Ross's data from the Falkland Islands in 1842. And in blue, you can see the sea level. And in red, you can see the air pressure, which Ross measured also. And because we know the inverse barometer works well in the Falkland Islands, the inverse barometer response is when air pressure goes up by a millibar, sea level goes down by a centimetre. And that works very well in that part of the world, and you can see that it agrees very well, very nicely. So this is a validation that this wouldn't work if either the sea level data was rubbish or the air pressure data was rubbish. So the fact you get this good agreement means that both are probably pretty good. So that would be nice. So we need the air pressure data as well. And the third reason is to collaborate with them is that the Met people are really good at getting funded. And they've got money from all over the place, even from Google and so on. So I think we need to collaborate with them. The lead project in that is this project called ACRE, which you can read about on that website there. This is led by Rob Allen at the Met Office. And of course, one of the well-publicised main features of this study is digitising ships' logbooks back to 1750. But I think so far they've only digitised about 10% of ships' logbooks. There are other projects like this. I mean, you might know about old weather, and but there are, anyway. ACRE is the main one, which I think we should. I think Guy has been to a meeting with ACRE. Yeah. Okay, so what we have to do is find out how much old data is out there. We have to decide how much is scientifically useful and determine priorities. We have to design techniques to computerise it. And like Gary said, we have to find funding for this important and urgent work. And the whole object of the exercise is to construct better, longer data sets with which we can do sea level science. So get to it.